So in this second video about angles and radian measurements, we're going to talk about angles that are in standard position as well as coterminal angles. So the first thing we do is talk about standard position. So an angle in standard position means that its initial side is on the positive x-axis. So this red segment here is going to be the initial side or the starting side of my angle. And if I then draw a second segment, this is called the terminal side. So my angle is going to be this angle right there. It's always traveling in that, or if it's traveling in that counterclockwise direction, that's going to be a positive angle. And if it traveled in the opposite direction, it would be considered a negative angle. So this terminal side can be, anywhere on the unit circle. So as it goes around, the angle gets bigger and bigger and bigger and bigger, or coterminal angle gets smaller and smaller and smaller and smaller. So let's pretend we had an angle over here that's measuring 3 pi over 4 radians. Well, what that means is that this measurement here, in terms of radians, is going to be 3 pi over 4. All right, it's 3 pi over 4 radians. And that's going to tell us that the, let me just write this a little bit neater for you. So that's 3 pi over 4. Well, the coterminal angle is the angle that goes in the opposite direction but still terminates at the same point. So the coterminal angle would be this angle here on the other side. So if this is going a positive 3 pi over 4, this here, first of all, must be negative. But the question is, well, how far is it negative? How many radians is that negative? And the answer is going to be, well, if this is going to be pi, and I went from pi to 3/4 pi, that means I must have gone an additional pi over 4. So this would be a negative pi over 2, a negative pi, and then another negative 1/4 of pi. So all in all, that's going to be the coterminal angle is going to be a negative 5 pi over 4. All right, and you may see that if I did 3 pi over 4 plus a positive 5 pi over 4 together, those should equal 2 pi. And that's how coterminal angles will always end up. It'll always just be the opposite direction. All right, and again, it doesn't matter which one we started with. We'll do one more. So let's pretend we had, instead of 3 pi over 4, let's say we had an angle down here, and we'll take the negative angle to start this time. So this angle here is going to be a negative pi over 2. All right, that's going to be a negative pi over 2 radians. Well, the coterminal angle would be the same angle in the opposite direction that ends at the same point. So it's going to go all the way around like this, and that would be my coterminal angle. So coterminal to a negative pi over 2 is going to be a positive, all the way around, 3 pi over 2. And again, if I did 3 pi over 2 plus a positive pi over 2 together, those should equal 2 pi. So that's how we're going to find angles in standard position as well as coterminal angles. The last piece we're going to talk about is linear speed and angular speed. So if we have a point that's rotating around this circle at however many radians per second, right? It just keeps traveling around and around and around. We can talk about two different types of speed. The first would be linear speed, and the second would be angular speed. Okay? And for linear speed, we're going to call it v. And we're going to say that v is equal to s divided by t, where s is going to be the distance it traveled. So however long that arc is, s is going to equal the arc length, divided by the time. So what this really is talking about, this is the arc length divided by the unit of time. And that's going to give me my linear speed. Okay, the angular speed, okay, is going to be found using a very similar formula where if I know that S is my arc length, and that's equal to R times theta, my radius times theta, okay, that helps me up here. The angular speed, which I'll call W, is going to equal theta divided by T, or in other words, this is my radians divided by time. And that would give me my angular speed. So this up here is linear, and this down here would be angular. So for linear speed, my answer would be in units such as miles per hour, inches per second, feet per minute, a unit of length divided by time, whereas in angular speed would be in radians per minute, radians per second, or maybe degrees per minute, degrees per hour, something like that. I hope this helps clarify a little bit about some of the terminology associated with angles and radians, and I'll see you in the next video.